Now I will talk about dimensionality. Dimensionality is important to know if our equations or relations are true or not. For example, we have this equation of motion v2 is equal to v1 plus at. It is correct, okay? If we need to know the dimensions, velocity is length over time. Velocity is length over time. Acceleration is length over squared time. The time is time. If we look at each term, then we will see that it is length over time, length over time, length over time squared with time. We can cancel time with the squared, then it is length over time. We can check that also by using the units. The units of velocity is meter per second. The units of velocity is meter per second. The units of acceleration is meter per square second. The units of the time is second. Then we can cancel second with the second. Then we have all terms have the same units, meter per second. So this equation is correct in physics. Okay, what about this one? This one is also correct. V square is has units meter over by second squared. V square meter per square second all squared. 2, it is all the numbers that appeared in our equations are unitless. So we don't have any unit for 2. The acceleration meter per square second. X is meter. Then meter square second square, meter square second square plus meter squared over second square, then it is correct. And if we deal with the dimensions, the kind of this variable, it is length over time squared. All of them are the same also. What about this equation? So this equation, this one is correct in physics. This is correct and this is correct. What about this one? V is equal to ax plus mt. M is the mass. The velocity is length over time. Acceleration is length over time squared. The x is length. We don't need to complete because we have length over time. We have length squared over time squared. It is not correct. If we look also at the units, the units of velocity meter per second, acceleration meter per square second, x is meter. We have the mass kilogram times second. When we see that we have a term with different units than the others, then this equation is wrong. We can't add mass multiplied by time to squared meter per squared second, which are not equal also to meter per second. If we look to the Newton's second law, we have in Newton the unit of force, which is ma, as the law say. Now, the mass is kilogram in units. The acceleration meter per square second. The weight is also a force with Newton's unit, which is mg. M is the mass, like this mass in kilograms, which is right. G is the acceleration due gravity, which is meter per square second, which is also right. What about this one? We have x equal to at cubed plus 2v over t multiplied by the acceleration a. We don't know if this equation is right in mathematics. In mathematics it's okay, but in physics, x in meters, acceleration is in meter per square second, t cubed second cubed plus 2 unitless, v is meter per second, the time 1 over time is 1 over second, the acceleration meter per squared second. Now meter here, which is the x. Here we have meter over squared second multiplied by cubed. We can cancel s squared with the cube, then we have ms in units. Also we have here meter squared over s to the 4, which is wrong in physics, as we see. This is the way to say that equation is right in physics or wrong in physics, and this is the way to analyze our dimensions for the equation. Thank you.